Hello everyone, my name is Shweta and today I'm going to be presenting our NoSQL application. The NoSQL database that we've selected for this application and the term paper is MongoDB. Here are my teammates with whom I've worked on for this project. Moving ahead to the introduction. Initially, we'll be talking about some of the main features of MongoDB from a high-level perspective. Then, we'll dive a little deeper and dissect these features with respect to three areas. First, data storage and indexing. Second, query processing and optimization. And third, transaction management and security support. Finally, we'll take a look at the NoSQL application, that is Airbnb, and we'll show you guys a little demo of it. So let's look at why we use MongoDB and why MongoDB is so popular. First, it's schema-less. What does that mean? So MongoDB, in contrast to the relational database management systems, is a schemaless database. So in relational database management systems, you have an architecture where the data is stored in different tables, and these tables are connected through some relations. And when you're trying to query some data out of these tables, it's usually pretty complex because you have to do some join operations. So in MongoDB, you don't have these features and you just have a collection which contains of multiple documents. Next, high performance. MongoDB provides much faster performance than the relational database management systems because it has superior indexing and query optimization features. Failure protection. MongoDB ensures failure protection by providing data replication, sharding, along with concurrency control and locking features so that your data is always available. Finally, it supports unstructured data. So it stores all the related data together into a single document, and it doesn't require the data to fit into rigid structures of relational rows and columns. So it doesn't require complex joins. Next, looking at the main features, first we have indexing and query optimization. So when we're designing the schema of a database, it is impossible to know in advance all the queries that will be performed by the end users. We have ad hoc queries, which are short-lived commands whose value depends on each variable. And each time an ad hoc query is executed, the result may be different depending on the variables in question. Optimizing the way in which ad hoc queries are handled can make significant difference when we have thousands of variables we need to consider. So MongoDB supports field queries, range queries, and regular expression searches to make things a little easier for us. Replication. When our data only resides in a single server, it is exposed to potential points of failure, such as server crash, service interruptions, or even a good old hardware failure. MongoDB provides replication sets. So your data is replicated on multiple servers, and if a primary server experiences any critical failure, one of the secondary server can be elected to take the place of the primary node. Sharding. Sharding involves splitting of large databases into chunks or shards. This makes it easier to access the data and also provides better support for complex queries. MongoDB offers horizontal scalability by sharding the databases through a lightweight process. This means that shards or chunks of a single database are stored separately in different clusters on different servers. This helps load balance and also ensures that there is no downtime. Load balancing. Being able to handle millions of client requests through thousands of servers is important for any NoSQL database. MongoDB does this in a consistent manner such that there is a significant difference in the performance, and MongoDB provides concurrency control and locking features that enables it to perform multiple concurrent thread read and write operations in real time. Moving ahead. Here we have shown you a ranking of all the database management systems, and you can clearly see that MongoDB is the most widely used NoSQL database system for the top tech companies. Next, we'll be moving on to data storage and indexing by Anuraj Jaiswal.
Thank you, Shweta. So, MongoDB is a data or MongoDB is a data-oriented database. Data for each individual rows is stored as documents in JSON format. These documents are equivalent to rows in relational databases. Multiple documents are grouped into collections, just like we have multiple rows in tables. Further, multiple collections we can have multiple collections per database, just like we have multiple tables per databases in relational databases. In the next slide, we'll see the data format. All the data under document is stored as JSON, which is nothing but JSON object, JavaScript object notation. Data is basically structured in key and value format. The supported data types are strings, integers, doubles, booleans, date. Apart from these, we can also have arrays of data and even another documents embedded as an object into the document. This is a bit different than relational databases, which does not allow lists, array of data, or multiple data types within one attribute. We can see in this example, we have strings, integers, lists, and even another object inside one key value pair. In the next slide, we'll see about indexing in MongoDB. MongoDB has wide support of indexes. It supports common indexes like B+tree, hash index, and text indexes. It also supports geospatial indexes, which can help in querying data on location coordinates. These were some of the features related to data storage and indexing. Next, Delzad will guide us through the query processing and optimization features in MongoDB.
Thank you, Anuraj. So, like any other database model, MongoDB follows CRUD operations for query processing. The nuances, although, are that each of these entries are in a key value JSON document, as mentioned by Anuraj. On the next slide, we shall see how each of these operations work and how we can use aggregation to make each of these stages as a quite streamlined process of writing queries. So we know how to write it in RDMS. So in RDMS, we usually have collections in RDMS, we have tables in which we have a proper structure, like a proper blueprint. In MongoDB, we have collections. In RDMS, we usually have a table to create a blueprint, as mentioned before, and then you can insert values. So this creates a way of writing multiple queries to be able to do just one task. In MongoDB, this one thing can entirely be aggregated as an insert query, and if the collection does not exist, it'll automatically be created and inserted. Another thing that we know about MongoDB is that all the key attributes do not necessarily need to be present in it. In RDBMS, we need to have all attributes present, because without a specific column, which is present when we are adding data, it might break. So we have to add null. But out here, we don't necessarily need to add null. We can just leave out that specific attribute, and later on, if required, we can check if it exists or not. This allows us to not just have an extra additional attribute which would unnecessarily just occupy space, but it allows us to even check whether if a value exists or not. This was only if you want to enter one entry, then you do insert one. But as we can see here, we can also insert many documents in one time itself. When we want to do this, we can take an entire JSON dump and we can put all those values, all those documents that we have pre-existing in a JSON format, and just push it onto the entire collection. Moving ahead, we shall talk about how we can read the data from a MongoDB collection. MongoDB collections usually go over documents and access records using the find command. In SQL, we usually go through by using select, and we can go over like select with a where condition, or just select all the condition, all the values inside. So if you want to work on a select star command in MongoDB, we usually do an empty find, or an empty find with an empty document inside it. This will fetch all the data present in that specific collection. Now, if you want to delimit whichever data is to be returned and displayed, we can talk about it in pipeline aggregations, which will come in the coming stages. And let's move on to the update. When coming to update, we see that MongoDB can update each document specifically based on a certain criteria, or we can update many records at one time based on that specific record. This we can do either by using regular aggregation pipelining that we'll again talk about in the future, or we could just set it on a specific condition. Like you can see out here, we are setting it just on a specific condition that if we see that the quantity is less than 50, then we are setting a specific value to a specific thing. And we are also changing the current date to last modified true. This allows us to have a very systemized approach towards updating our data by allowing you to update many attributes, many entries in one time. Moving on. These rules also apply to delete, where you can either choose to delete one document or one entry based on a certain search criteria, or delete all of them, or delete many of them. You could delete all of them by just, as previously mentioned, you can just delete it by just having an empty document inside the delete command, or delete many of them on a specific search criteria. I like it's shown out here, like all those documents which have status A shall be deleted. Now we shall talk a bit more about aggregation. So aggregation pipelining is basically using all those SQL functions that are present in RDBMS and converting them to specific attributes in an aggregation operation. As we can see in this table, a lot of these functions which are there in SQL are present in MongoDB also, but we can't directly use them in a find or in a specific command. So in MongoDB, if you want to join, or if you want to specifically have multiple pipelining or multiple stages of retrieving your data, you can just easily do it by using an aggregation pipeline. The only caveat to aggregation is that the current state will only have the parent state. Output of the current state, the output of the previous state will have only the data that is present in the previous state. So you cannot, if you 3 stages back, if you've performed a query, you will not be able to retrieve that in this current pipelining stage. So that is an important thing to look up on. Talking about lookups, we can see that even though we mentioned before that joins are not a good part about are not present in MongoDB, we do know that if they have 2 separate collections, they must be joined up on a certain condition, which we can use by using a $lookup in aggregation. This does not mean that we need to join on specific relations or specific wheres or specific criteria, but this is just basically 2 isolated, unique, different collections that we want to join together. Next, we shall talk about performance and optimization. It is not very popularly known that MongoDB allows you to analyze query performances by returning actual data statistics. So this is a good chance to learn how to do it. We can use cursor explain or a dot explain execution stats to retrieve all the documentation that is required, which goes on behind the scenes. So MongoDB may have indexes present, but is the index the best choice to use or not is decided by the MongoDB engine itself. Whether to use an index or not is up to MongoDB. And if you want to see if an index has been used, then you could use execution statistics to check it out. We could also specifically find a specific execution statistics that you want by using a cursor.explain.find and find whatever we were looking for. Like, let's say if you were looking for if the execution was a success or not, we could just do an explain.find on it. And regular MongoDB queries also apply on a cursor.explain. So to say, we could continue to call it like a collection per se. This return execution statistic information will tell you only the winning plan. So if you would want to know whether an index exists or not, then this is not for you. This is only to see that whether the index was used or not. Going over the optimization, we've listed out four optimization strategies that are present in MongoDB and that we usually use in our day-to-day applications. One is index creation, as we've talked about before, that an index creation will reduce the read-write operations, which would exist. The read operations on the database access. How so? So since lesser data is accessed, since lesser data is supposed to be looked up, the queries are returned faster and it's better. Selectivity, the narrower the scope and the more bottlenecked a query is, the more selective we can say a query is, and higher the performance will be for that query. Talking about query covering, or a covered query is an excellent query, but it's very hard to find. It's very niche. Why so? The results for a covered query are present directly inside the index itself. This means per se that the attributes need not be looked up from the documents, but they are present in the index itself, and we can easily access it at a blazing fast speed. Although there is another feature that says that a covered query will not have any null attributes present in it. So that is something to remember. Multi-key index covers more like a covered query with an index feature in it, combining two of the optimization strategies used above. It actually goes over multiple indexes which have multiple keys present in it. So let's say we have two or more indexes with certain keys. The query, if it's present in any of these, if we have attributes that are to be selected from any of these, they can and will be retrieved at a blazing fast speed. So that's all from me for optimization. And now we should go ahead to Tejas, and he can talk more about transaction management.
Thank you, Dilzad. So moving on to next slide. We'll talk about transactions and what they are. Transactions are basic activities in any database management systems to achieve business goals. MongoDB supports single document as well as multi-document transaction support and guarantees ACID transactions for its documents. These satisfy around 80 to 90% of application requirements, and we'll also talk about the other 10% and how multi-document ACID transaction support supports those use cases. So moving on to next slide. By support for multi-document transaction support, the burden of implementing has been taken off the database developers, thereby reducing the application development time and performance overhead. As mentioned, MongoDB already takes care of 80 to 90% of use cases with its single document ACID support. Some heavy workloads that are now supported through multi-document ACID guarantees are, moving on to next slide. System of record applications or line of business applications. System of record applications are critical data infrastructures in organizations which hold huge amount of company data and may act as a source of data truth within the organizations. Line of business applications are softwares or tools or computing resources that organizations use to solve their business problems. Moving on to the next slide. Now we'll talk about snapshot isolation in MongoDB. Snapshot isolation guarantees complete isolation in case of document updates, subdocument updates, and updates to information within the documents and their arrays. For read operations, MongoDB provides isolated view of the document with the primary replica of the database. For write operations, MongoDB obtains transaction lock on the document until modifications are complete. In case it is not able to obtain the lock, the transaction times out after 5 milliseconds with a write error, and the data rolls back to its previous view to ensure data integrity and consistency. In regards to comparison with RDBMS, both RDBMS and MongoDB provide ACID transaction guarantees. MongoDB also supports multi-document transaction support, enabling development of highly scalable data management solutions. Now we'll talk about some of the security features that MongoDB provides. MongoDB has a wide array of security features, ensuring data does not fall into the wrong hands. Some of supported features are authentication, authorization, encryption, and some of the enterprise features, and we'll talk about them in brief now. Authentication verifies user's identity using username, password, and the database URL to authenticate the user. Some of the available methods to authenticate users in MongoDB are SCRAM X509 certificate authentication, lightweight directory access protocol proxy authentication, and Kerberos authentication for their enterprise features. Moving on to authorization. Authentication occurs when authorization is enabled. So authorization essentially manages the scope of privileges the user has over the database and its resources. MongoDB uses role-based access control, or famously called RBAC protocol, to determine the user's privileges. Now we'll talk about some of the enterprise features that MongoDB provides. With the various suite of security mechanisms such as AES 256, cipher blocker chaining, transport layer security, SCRAM, among others, MongoDB ensures compliance with security standards such as HIPAA, PCI DSS, etc. to protect confidential information. MongoDB also has auditing capabilities to monitor deployment activities and database itself. Some components that can be audited are database schema, clusters and other resources, user authentication, resource authorizations, and CRUD operations. Moving on to, we can move on to the next slide as well. Thank you. So both RDBMS and MongoDB have RBAC and MongoDB. Both RDBMS allow document encryption, and all the communication in MongoDB is encrypted with TLS SSL protocols, like many other relational database management systems. Now back to Anuraj. He'll talk about the NoSQL application that we've been working on.
Thank you, Tejas. All right. So to make best use of features of MongoDB, we have implemented an Airbnb clone. MongoDB was the perfect option here, as every listing that is to be displayed for a particular search query contains vast amount of data regarding the host, location, property, policies, reviews, cost, images, and availability. Each one of these contains multiple sub-information and further can contain either lists, arrays of data, or further categories of data. Thus, to review such data, we would require multiple joins if we would be using a relational database, which would make the application very slow and unusable. So in the next slide, we'll see our design and architecture for the NoSQL application that we created. We'll use React to design the front end and use REST APIs to fetch the data from the backend. A backend is a server deployed using Flask application, which is a Python-based server framework. Here, we also have a MongoDB hosted as a service. Both the Flask application and database is containerized using Docker, which will also help us if we decide to scale our application horizontally. Next, we will now see our application in working.
Thank you, Anuraj. So let's go over the demonstration of our NoSQL application, in which we shall demonstrate how MongoDB was useful for businesses like the Airbnb clone that we're just going to demonstrate to you all. Let's say we have a user who's just coming here to register himself for a first-time user. Let's say John Doe. Call him John Doe, and his email is johndoe@gmail.com, and he has a certain password of 8 or more characters with all numeric and special characters included. We accept and we continue. So only after we validate him and we check him into the application, we will be able to see this search bar where he can customize and search his queries from any page of the application. Here we see that we have the option to filter and choose which check-in date we want, a checkout date we want. We have number of adults, number of children, and each filtering query will be able to retrieve different values for us. Let's say somebody wants to just check out any random listing or any random real estate which is available. Then you can just click on a specific, let's say today, and for about a week. We don't want any location, just give me the top best locations and search. So we have a few locations that will be retrieved that will tell us that, hey, these are the best locations that are available. Why don't we check them out? And this will be arranged in a randomized order, but based on the best ratings. Coming back to the initial page of the application. Let's say we want to search on a specific place. Let's say location as Austin. Again, I'm going to take it for a specific amount of weeks, and we have $1. We search. So when this query is happening, we have an index which is taking place at the back, and it's going to index it based on the location, and all the real estate present in Austin will be displayed, and we can see all the locations out here. Let's go back. Similarly, let's say we have New York. We check in for a short amount of time. Let's say from 19th to 21, we have 3 adults. Let's just keep 1 adult for now. We don't want more people. We just want our privacy. We search for it. We've got all our details here. So we notice that when we search for a different location, we get different results, but it's pretty quick because we have an index on MongoDB. And each of these fields that we can see out here have all been accessed through MongoDB using the dot operator, since we have documents. When we click on a specific route, we see that, hey, this is the name of the place that we have, the location, number of reviews, and we have this floating container in case we want to change the check-in and check-out date and the number of guests. We have a carousel so that we can move ahead and behind, and we can see the different photos which are available on our listing. Here we see again, we've got the name and the host name, Angela. If this was a super host, then we would mention it that, hey, this is a super host. Here we see that we have the number of guests, the maximum number of guests available, the number of beds and the bathrooms available, the description of the house. We have the amenities present in it, like we have the cable TV, refrigerator, essentials, and these are all the things that have been offered. Now we can see that the dates that it's available for also, which is present out here, and we can just clear the dates if we've selected any. We have reviews for each specific criteria, like cleanliness, communication, check-in, check-out, everything. We can just, depending on whatever's available, it'll be shown out here. A different different review, which is present in a different location, may be different. As mentioned in our PowerPoint, that if there is a specific keylog present, only then it will be displayed, otherwise it won't. We have the map also embedded so that we can see the businesses which are around and near our specific hosting, and this is just the place where it is located. A few responses a few details of our host, and this is what her bio is. This is the response rate of the hoster and the reviews that have been given to the specific host. Now, this is for this specific route. Let's say we go to a wrong route. Let's say we have a link and we just go to, let's say, potato. There is no route called potato. So let's see what we get. Oops, a page not found. So since that specific route is not available, or let's say the host has removed that link, or if the host has removed that specific housing, then we will reach this page saying that, hey, this thing doesn't exist. So let's just go back home. We're sorry, we didn't find anything with respect to that specific house. Coming back, now this is, we come back to the home page because we navigated, and that ends what we've had. Since I'm the user, I finished what I wanted to do. I'm just going to sign out, and boom, I'm done. Thank you so much for going over our PowerPoint. We hope you learned a lot about MongoDB, and if you have any questions, do let us know. Give us, you could always let us know in the discussion section, or you could comment on our YouTube video. Thank you.